Without any further ado here, I'd like to welcome John Adam to the stage. He is a Associate Vice President for the CP Tech Center, Concrete Paving Technology Center based out of Ames, Iowa. They're kind of a research arm, or one research arm, kind of tied in with Iowa State University that is publicly funded through a whole bunch of other, I'll say, concrete-related associations. The ACPA, NRMCA, our national affiliates being two of those. So today, John's going to be talking to us about a fresh look at concrete pavements for local agencies. This is I guess, a technical manual that I sat on with John and about 14 other individuals, and over the course of the last year, kind of got everything formulated and put together here. And John was one of the individuals that really kind of spearheaded those efforts for us. So without further ado, please welcome John Adam.
Thank you. Good morning. It's interesting to be here in this weather because last two times Brian had me out here, it's been in the middle of a snowstorm. So this time I thought, I don't know if I want to go up here in March, but it's really pretty good here. And Iowa's the place that's getting the blizzard today. So thank you, Brian. It's excellent timing, kind of surprising, but excellent timing. So he talked a little bit about the CP Tech Center where we are at Iowa State University, and we work with industry and agencies and academia and try to get all these people to the table and collaborate to advance good concrete paving practices and get them out into the world. And what I'm going to talk about today is one of the products that we've been working on. And this one emerged, Brian mentioned we work with Federal Highway Agency quite a bit, or they help sponsor us. We have a grant with the Federal Highway Agency, and we collaborate with them to produce tech training documents, not so much research, but tech training primarily, and get this stuff out there into the world where it can be put to use. So one of the projects, and this was actually brought up by FHWA to the CP Tech Center, they would like to see a project that focuses on non-state agencies. So many of our documents and products focus on state agencies, the DOTs throughout the country. And the thought was there are a lot of agencies out there that really don't get the benefit or the knowledge, have the up-to-date awareness of what's going on in the concrete industry, and some of them have fallen away entirely from using concrete. And a lot of these agencies do receive federal funding, so the thought was, well, we should find a way to help advance concrete paving in some of these agencies, some of these places that don't typically use it. So that's what this project was intended to do. So tribal agencies, parks departments, counties, particularly a lot of municipalities. So a lot of these places receive federal funds, but a lot of them do not touch concrete paving. So the idea here is to let's put together a group and figure out how we can get this information out to these places that don't typically use it. They're not up to date with the technology. Let's get it out there in such a way that they would become interested and utilize it. So we put together a group. Here's the project team, myself and Robert Sprague, but the bulk of the work was done by Jared Gross at Snyder & Associates and Jerry Voigt. A lot of you know Jerry Voigt. Jerry really put a lot of flair into this document, and we really appreciate what he did. And then Eric Farabee here had some input on it as well and helped at the front end of this, get this thing going. We didn't just have these folks write a guide or a manual, so we put together a technical advisory committee and really find out what's going on out in the communities, out in the various regions. What are they dealing with? How do they interact with some of these smaller agencies? So we have here, and this is, we have a combination of industry, agency, consultant, and so on. So Rich Brum, we contacted Rich. He's a county engineer in Iowa, on 2 counties in northern Iowa, but he does an awful lot of concrete paving and a lot of concrete overlays. I mean, he's been doing them for years and years and has a lot of insight on that. Amy Waddell, Florida Concrete Products Association, Angela Folkstead, Colorado, Wyoming Concrete Paving Association, Jesse Jonas from St. Louis. Paul Wiggin is a former public works director for the city of Ames, Iowa, and then later took on the statewide urban design standards and specifications project we have in Iowa, which basically uses the same standards and specifications for municipal work all over the state. National Ready Mix Concrete Association, Brian Killingsworth, Matt Zeller from Minnesota, Heath Schaff, Vinton Construction in Wisconsin, and your own Brian Zuroff was on the Technical Advisory Committee. So we met a number of times online, and it was interesting as we got through this. You know, we started out thinking this is going to be just a how-to manual for local agencies. And as we discussed this with the technical advisory group, it became, well, it's not just a how-to, but how to get them to. How do you get a local agency to think about concrete? How do you get them up to speed when they haven't been? Maybe they haven't had and still don't have any interest in it. So we talked about what kind of a value proposition can we present to them. So a lot of this starts to look at what are the positive aspects of concrete paving that would resonate with a local agency. Then the other part of that, the question is, well, what prevents them? What do they hesitate? What are their hesitations about using concrete paving? So we got into some of those things in here and addressed them. So we identified the positive, identified the perceived negatives, and tried to address them in the front end of this. And then the back end of the manual or the guide is kind of a how-to part. So that's how this was put together, how it was conceived, and here we have, you see a photo here, a municipal application, and the point here is these projects can be done where you can maintain access to properties in ways that people who have preconceived ideas may not realize. So we want to present some of these options out there, make them aware that things can be done, be successful in this arena. It's an example of a number of applications here, park roads, bike paths, and so on. That's another one we're seeing more and more use in park situations, golf course, bike paths, all these kinds of things. County roads, I already mentioned, we do a lot of that in Iowa, county roads, overlays in particular. And with the agricultural loads we have, you probably have them here too, plus you have the mining stuff. You guys have heavy loads. So our county system really is swinging over to concrete pavements because of the load carrying capacity, and some of the, quite honestly, the asphalt products don't hold up to some of the loads they're seeing, particularly the overweight agricultural loads that we get out in the country. Intersections, urban arterials, the intersections too, and we'll talk about that a little more, but where you have severe, the stress on the pavement from the starts, the stops, the turning maneuvers, and so on, and where you have asphalt in intersections and those kind of movements, it's not unusual to see some severe distress and rutting and tearing and so on, and maintenance problems. So we're seeing more and more intersection concrete reconstructions, and we want to present that as an example to some of the local agencies, something to think about. So it was set up in 6 sections. A fresh look, the key benefits. So that's where we're talking about what are the positive benefits, what are the reasons, the advantages to go with concrete. And again, this is set up to be a tool or a mechanism where somebody like Brian or maybe a contractor can go into a municipality and sit down and talk about these things in a way that might resonate with them. So key benefits, solutions to common project challenges, implementation considerations and steps, preservation, and where to find resources. The Technical Advisory Committee, I mean, one afternoon we spent hours talking about what are the benefits of concrete paving in some of these local applications. And there were more than 9, but we came up with 9. You see them here on this graphic that's shaped like a wheel. And in the center it says sustainable concrete paving. And we're not, I guess I don't think that is the carbon thing. It's more, in my mind, and I think what this demonstrates, it's sustainable, which means it has long life, it's economical, and low operating costs, low maintenance. Nothing is more sustainable than the project that lasts as long as it's supposed to last and possibly beyond. I mean, that's what sustainability is. So all these other aspects around this circle all lead to sustainable concrete pavement. So looking around the wheel, number 1, long life. Let's see, yeah, long life through durability. So we talked about that, and Matt talked about that too with some of the PEM and gradation stuff. All that ties in together. The second one, the argument that there are infrequent maintenance needs. So a properly designed and constructed concrete pavement will last a long time. You will not have to go in and do serious maintenance for probably 20 or 30 years. And that's a big selling point, I think, for a lot of agencies. Superior load carrying capacity and strength. And again, we see that in some of our applications where you have trucks, heavy equipment, and so on, a lot of impacts that need to be dealt with. Concrete is a good solution for that. The start-stop issue at intersections, number 4. Resilience during flooding or saturation. We'll spend a little more time on that, but I think that's getting more and more important to some agencies. I also mentioned this as we talk through this isn't just highways, and it occurred to me, we're working with the Federal Aviation Administration too on concrete improvements and some research and so on, but everything we're talking about here would also apply to airfields, maybe county airports and under the jurisdiction of the county, generally aviation airports. This stuff all applies there too. So, we didn't put this together. We were thinking in the highway realm, but I think this all applies beyond that. But anyway, resilience during flooding or saturation. We're getting more and more flood events, and we'll talk about that a little further in a few slides. Light reflectance for safety and heat reduction. We're seeing interest in that in some of the southern states that really have to deal with some severe temperature and weather conditions. Skid resistance, surface texture for safety, and how we get good texture with concrete and it stays that way. It doesn't, unless you're using studded tires or abrasives in the wintertime, you're going to maintain, there's no reason not to maintain good friction for a length of the project. For cities who do enhancement projects and so on, concrete is a good opportunity to put together those kind of projects that create a nice environment in their downtowns or their park areas and so on. And then the big one is low ownership costs over time, and we'll talk a little bit more about that. But those are the 9 factors that this group really came up with that should resonate with a local agency. So we talked a little bit already about sustainability and performance. And the performance engineered mixtures is one of the big issues, or a big opportunity, I should say. And an agency that hasn't touched concrete in 10 or 20 or 30 years probably isn't aware of performance engineered mixtures and the improved performance we get out of this, and use of supplemental cementitious materials that help prevent decracking or alkali silica reactivity, all these things. Better selection of aggregates to avoid freeze thaw. So if an agency had a experience 10 or 20 or 30 years ago, and that's what sticks in their mind, they don't want to touch concrete again, they're probably not aware of some of the stuff that's gone on, some of the advancements, some of the opportunities we have now that improve mixes. Type 1L cements, whether you want them or not, you'll probably have them, and Matt talked a little bit about that, doing trial batches and so on. So if somebody's afraid of 1L cements and the changes in the industry, there are ways to deal with that and still get your good properties. And some communities still are interested in lower carbon footprints. If they are, this is something of a selling point for them. I think a lot of that has waned, which is fine, but for those who are, this still can be a factor. And optimized material selection and proportioning, reducing the cement content and the paste, which reduces the shrinkage issues, reduces the cost, and improves workability, improves smoothness, all this stuff. So all this stuff goes together to have the opportunity for a much improved mix over what some of these communities may think concrete is, because they're thinking of something that maybe used to be 30, 40 years ago. So we need to bring them up to speed. And that's what this document is intended to help with. One example is, the ADA requirements for crosswalks, and concrete being a very good application for that, because once they're in place, they're built correctly, they don't lose their dimensions, they don't lose their dimensional proportions, everything stays in compliance for the life of that facility. There are other cases where other products, that may not be the case, where you end up with some severe rutting through there or whatever it might be. So we're seeing, this was offered by some of the people on our technical advisory committee. It's kind of an abstract thing, but for those in the cities that look at this stuff, it's an important issue. So we made sure to put that in there. So going around that wheel again, life and longevity, long life and longevity. So, concrete, you're looking at 30 to 50 years, probably 40 to 50 anyway. To me, in my mind, a 30-year concrete pavement hasn't, I think I wouldn't call it a failure, but I would expect 40 to 50, quite honestly, when we construct these. So an agency that constructs these can expect to not be bothered again by a major rehabilitation or anything for quite a long time. We talked about PEM principles already, just a little bit, but these things all help for the durability and the long-term performance. By the way, so performance engineered concrete paving mixtures, there's a document at the CP Tech Center that could be downloaded that gets into all that detail. I would also say too, the idea wasn't to put everything into this document. It was to put enough in there to inform people that this is a good thing to look into further, and maybe that applies to our situation in our county or city or park or whatever it is. So there's a lot of links to other documents and so on. So we tried to keep it small enough so that, if you come in there with the 150-page manual, people don't want to look at that. But if you have something that's 40 or 50 pages that really hits the high points and gives some examples, we're hoping that's a little bit easier to get out there and get people interested in, and then go on to the next step of involvement. Infrequent maintenance needs, the second point on the wheel. Long service life, minimal interventions. So maybe it's 20, 30 years before you have any kind of a rehab situation at all, or a serious preservation. And then it may only be grinding or something. So you can do some preservation. And we have the preservation guide, which was mentioned earlier. I think Eric mentioned this. So there's information out there on what to do when and when's most effective, and the cost effectiveness of various treatments and so on. So all that's, they're directed to that as well through this guide. Load carrying capacity and strength, that's pretty self-explanatory. Resistance to rutting and fatigue. Wide load distribution, that's a little more important point I want to focus on. Low pressure on subgrade makes pavement less sensitive to variations in subgrades. In other words, it's a little more forgiving if you have some subgrade or subbase inconsistencies. So you may not even notice them where, say on an asphalt pavement, which, a flexible load transfer, weaknesses in the subgrade are not going to be bridged very often, and you may end up with some distress. And here's a graphic that shows that. So sorry. Yeah, they are not tied together. My apologies. Okay, there's where I wanted to get to. So, load carrying capacity and strength. So with the flexible pavement, because of the flexible nature of it, the load is transferred more directly into the base and subbase, as you see here. And then on the concrete pavement, due to the stiffness, the rigidity of the concrete, and the strength, it's spread out over a wider area. So less PSI, less strength is needed in the base and subbase. And one of the things that this also leads to is in cases of inundation, flooding, where you lose the strength in the base and the subbase, in the situation for asphalt paving, you can cause a lot of distress. It might be quite a while before you can get back on that pavement. In the case of concrete, and this is I-29, I think, in North Dakota, as a matter of fact. Maybe you provided that photo. I'm not sure, Brian. But the point is, when you have concrete will stand up to a weaker subgrade. You can put traffic back on there almost immediately without any decrease in the life of that pavement. And that really becomes important in situations of the emergency operations. I want to focus on that a little bit, because when you have a flood situation, everything's a mess, and you come back into recovery, you want to be able to use that pavement as soon as you can for emergency vehicles. You're hauling debris out, getting heavy equipment in, all this stuff. We've seen that in the Carolinas last fall, I think it was. These hurricanes come through, and they have these situations. And in the case of flexible pavement, you start putting those loads on, it's still saturated underneath, you've lost a lot of life in that pavement, if not complete failure. With the concrete ones, the resilience is there, you're able to put loads back on them and not experience distress or shortening of the life of that pavement. And that's been demonstrated through research as well. And the FAA is interested in this too, and there's a project, I think Matt Fonte might be involved with that, I'm not sure, but where they're looking at resilience of airfields and so on, and with regard to concrete, and preserving the operational capacity of an airport when we have flooding situations. Toughness in the start areas. We talked about that already. Durability under high stress. There we go. Light reflectance for safety. Some of that in the heat island mitigation. I'm going to talk more about heat island mitigation, and though I don't think there's a lot of problem with that up here in North Dakota, but down in the Southwest primarily, we're dealing with that. And even in some areas, they are actually, and this is Phoenix, and they're actually pigmenting asphalt pavements, trying to lighten them up to mitigate the heat effect of asphalt and the extreme temperatures that they get when they get weeks and months of 110 plus degrees every day. So they're trying to reflect it back off. And I think the suggestion would be, well, why not just build these as concrete to begin with? So skid resistance, surface texture for safety. Certainly get good skid resistance. Do you tine in North Dakota, I guess? Do we here? I think Minnesota does not. So I think you could argue for a municipal situation, for instance, you wouldn't need to tine, especially low speeds and everything. You're going to get adequate friction, and it's going to maintain that adequate friction for a long time. Let's move ahead. Another opportunity, streetscaping. We see some communities, concrete paving, concrete approach gives them a lot of opportunity to do these kind of things. A lot of very visually appealing areas can be developed, park areas, community areas. So it's another selling point. So you can see here crosswalks, streetscaping of various kinds. Roundabouts. Now Eric shows us how to do joining on roundabouts. We don't need to be afraid of using concrete on roundabouts. The other thing with roundabouts, I would say, especially if you have heavy traffic, you know, these slow speed, heavy traffic, maybe trucks and so on, the concrete would be a good solution for those rather than asphalt, I would think. So low ownership cost. It's probably the biggest selling point, at least in my mind, because I used to work for the DOT in Iowa. You know, we'd try to program our dollars out, and you always have a problem make your money stretch. And I think here, upfront cost, we're finding in many cases are not that different from asphalt. So communities or counties or cities that think, oh, I can't touch concrete, it's too expensive, that's not necessarily the case. And then you look at the minimal maintenance that you have to do. Your facility remains open, you don't have all the traffic control messes and bothering residents and so on. You don't have to program in all that maintenance you might with the asphalt pavements. So life cycle cost is really, when you look at the life cycle cost, it's the way to go quite often. So misperceptions. Some of the things we talked about, well, why don't some agencies want to look at concrete paving? And some of the stuff you hear, it takes too long, it's inconvenient. You know, we don't want to inconvenience our residents, or you got to shut down for 6 months or whatever it might be. The other one's too hard to repair. What if I have to fix some utilities? It's it's easier just to go out and dig up asphalt, right? And then it costs too much. So we took a look at those. And solutions to maintaining access. So there are ways to do that. There are ways to do projects and maintain access, keep the residents fairly, pretty happy. And nobody likes to be inconvenienced, we know that, but there are ways to do things. It's not just, I'm going to go in and shut down, a couple of miles of this for 2 months. There are ways to phase things, phase closures, make temporary accesses and so on. So these communities or these counties or cities who don't want to think about concrete, they need to understand there's ways to deal with what they think have always been problems. Contractors can be very creative in finding ways to mitigate these things and work with the residents, work with the communities and so on to get this stuff done with the minimal disturbance and dislocation of businesses or any of that kind of stuff. The bottom point here, I think the important one of the most important ones, I think, is allowing contractor flexibility. So contract documents, if you can, in these communities, could set them up such that you don't tell the contractor how to do stuff. Just tell them what you want done, when you want done, what some of the issues are, and then let the contractor use their experience and their creativity and their ingenuity to figure out the best way to do it. And if you say, all right, I've got a project, I want this open by this date or that open by that date, and we want to do this with the traffic, then let the contractor figure out the rest. And we found, many cases that's the best way to do that. The agency doesn't need to figure out all that stuff. They just need to figure out what the important points are, let the contractor handle the rest of it. So that's a big point we want to try to get across in this guide. Time, time required to open pavement to traffic. So if an agency or say a city engineer or public works guy hasn't worked with concrete in a long time, they might think that, well, concrete, you place your concrete. We can't get on that for 7 days or 14 days or some amount of time, which of course is not the case. And we want to get them thinking about strength-based opening criteria rather than time-based. So there's research out there now. There's a lot of a lot of documentation that generally opening strengths have been overly conservative over the years, and we can be a lot less conservative on when to open a pavement to traffic, whether it's local traffic, contractor traffic, or the full opening through traffic. And there are ways to do that and determine the strength gain. The maturity method, some of you are probably aware of that, but I would guess many people who haven't used concrete in a long time may not be aware of the maturity method and how to use it and what it tells you. So by using the maturity method, for instance, you can accelerate when you open the project, let the contractor be a lot more innovative and efficient in how they go about their work, let them on there earlier. Minnesota did some work a few years ago at Min Road. Some of you are familiar with Min Road, but they did a section, loaded a truck, drove it on like 2 hours, 4 hours, 6 hours later. And even the first ones actually left ruts in the pavement, in the concrete. It hadn't quite set up yet. But yet then they went back and evaluated that. There was no distress, no permanent distress in any of it. It still cured up fine, and there was nothing wrong with it. Not that we recommend driving on it that soon, but the point is, concrete can take loads a lot earlier than many people think it can. So here, the maturity method, the AASHTO T413, and this is a new method that came out in November. Now, maturity's been around a long time in different fashion, I guess. It was primarily designed for structures. But what it does is it measures the heat over time. As concrete cures, it gives off heat through the chemical reactions. So this evaluates heat and time, and by doing that, it can estimate strength of the pavement. And this T413 is designed, this was written specifically for concrete paving, so it takes actual mix from the road, so real mix, not lab mix, so real mix, and it focuses on the first 2 to 3 days of material and paving and so on, because that's when you want to get the value out of the maturity method, figure out when you have enough strength, opening strength to let things continue to use that structure, opening it up. And we found that on flexural strength, I know I was gone down to about 350 for beam strengths to open to traffic. And that's not the same as, so if you have a specified strength, whether 4,000 PSI or wherever you might have, that's not the same thing as opening strength. So, as a matter of fact, somebody mentioned, Matt did, some of these projects they'll continue to develop strength over time typically, especially with the 1Ls now. So if you know you have enough opening strength early on and can open it up and let the contractor find efficiencies in how they stage the project, you can let residents back into their property after a day and a half. It's not so bad. You can work around these things. And so agencies may not be aware of these kind of tools out there, and this can help them understand there's ways to get these things done. So pavement costs, the guide here will, it doesn't do examples of life cycle costs, but it has sources that are linked to it and ways you can get to it to demonstrate that. In I guess a quick graphic, this shows the concrete pavement on the bottom and asphalt on the top. The serious rehabilitation projects that have to be done on an asphalt project, typically 30 years or so, versus perhaps just regular maintenance, some grinding, some rehab, but nothing, you're not reconstructing every 30 years. Utility accesses. So another argument in municipal areas sometimes is that, well, if we have a problem, we want to be able to get out there and take care of it. It's hard to do with concrete paving. We'd rather just have asphalt. You can get a bucket out there and dig that stuff up. But really, there are efficient ways, and this guide goes into how these repairs can be done. And it really demonstrates that there's not a lot of difference in effort in repairing and patching and dealing with the utility cut between concrete and asphalt if it's done properly. I mean, you saw it and you dig it out and you fill it back in. And you can do it with, this is, I think ACPA provided this. This is from one of their documents, but it just demonstrates, going in and repairing a utility situation. So we try to provide those kind of examples in here a little bit, and again, take the hesitation away from those who have some kind of an argument to not do this. The main features of a concrete pavement are shown. We don't get into the full design in this guide, but it focuses on mainly plain jointed concrete paving, showing the base, sub-base dowels and so on. Talks a little bit, enough about this so people understand what it is. But again, it's not a design manual. For design, for instance, thickness design, pavementdesigner.org is a free web-based software that agencies can use to get involved in, or consultants to do their design. So it's not complicated, and they can be led through that process. We talked about subgrade in here a little bit. ensuring the subgrade uniformity of subgrade, heaving and swelling issues, treatment of subgrade. Again, it talks about these issues, but it doesn't necessarily do a deep dive on any of them. But it's just to give an overview that these things are out there, they can be handled, and links to other documents that can help guide through any issues. Base layers, there's a recommendation for aggregate base layers to go in here for drainage, for support, and so on. Some agencies may be, what they understand would maybe be just to put concrete on a natural subgrade or something. And so we want to make sure that they understand the value of a subbase, an aggregate subbase here. And we heard a lot about joining already today from Eric. So joining is addressed in here. Again, concrete shrinks, so we need to control the cracks, thus the joints. So helping people understand some of the basics here, take some of the, concrete cracks. Everybody, I mean, there are some that think, well, cracks, I don't want it on my roadways. I'm gonna have to deal with that, but you know, cracking is part of the design. So how do you implement this? We talked a little bit about, all right, so if you want to get this in front of somebody, help them go from no concrete or little concrete to, say, a sustainable concrete program that they have with their infrastructure funding. So one of them is to plan and collaborate. Do they even have concrete as in their mix of fixes, so to speak? If not, they need to start thinking about it, and somebody like Brian maybe can help get that going. Start to develop some competency in their agency or organization. There are a lot of specifications. There's a lot of canned stuff out there, let's say, basic specifications, standards that can be used and modified as need be. So an agency or a consultant doesn't have to start from scratch. It's all out there, and usually with a little modification can be applied to just about any situation effectively. Help them understand how to address traffic, and then I would more broadly say not just traffic, but the impacted residents and businesses and farms and everything else along that route or situation. And staff training, get people trained up. There's a lot of training opportunities out there. There's a lot of materials. ACPA has a lot. CP Tech has a lot. There are training modules that can be brought on site, and there are a number of opportunities. A lot of them are very little or no cost. And then scale up success, start with something small. If you can get them just to get started with something, build some confidence, see some success, and then build on that. So the group, this is what the group came up to with some implementation steps are in the guide, and hopefully we can get out there and apply these and get some work going. There are a couple of case studies in this book too, just to show or demonstrate that some communities have really gone 100% to concrete. Overland Park, Kansas, due to with asphalt pavements and streets, all the maintenance over the years, they just analyzed all that and decided to go with concrete paving on all new and residential and collector pavements. And then the village of Kimberly, Wisconsin has been 100% for a long time. I think you mentioned Fargo is mostly concrete, right? And Bismarck. So some of that's already going on here. Oops, let me back. Just one more thing. So this document is not out yet. It's since final, I guess, editing processes. It's with Federal Highway right now as they look at it, and hopefully we get their blessing, and then we can get it out in the street sometime this year, sooner rather than later. So that's what we have going on, and I hope this document will meet your needs and will be of value to try to get concrete out into some of these other non-traditional communities. So.
Yeah, awesome. So one thing to note on that, John's right. So we've been working on this document for a little bit more than a year with the Technical Advisory Committee and working with Jared Gross with Snyder and Associates CP Tech Center on getting this developed with Federal Highway. My understanding is it is currently sitting in attorney review at Federal Highway. We were, prior to DOGE, anticipating this probably being out like in that June, July timeframe. Now, what that's going to get actually modified to and the actual review timeline, we're kind of shrugging our shoulders. But the one thing I will note to mention here is North Dakota Concrete Council, North Dakota Ready Mix Concrete Products Association, American Concrete Pavement Association North Dakota chapter has already indicated to CP Tech Center and Federal Highway that we are interested in purchasing a couple hundred copies, hard copies of this document. The document will be free, available online. Our intent with purchasing a couple of hundred hard copies is to make them free to view to really anybody within North Dakota. We want to get this in as many hands as possible. When we get a little bit closer and have a little bit more hard date on when that's actually going to be released, we'll kind of have what I'll say a free order form on our website that we'll be launching here. And we'll just kind of be spreading the word out again through our newsletter, various communications. If you guys are on our email blast list, you'll get an email from Savannah kind of when that time has come. But if you guys if there's any consultant engineers that do a lot of work with municipalities, municipalities, agencies themselves, contractors, anybody that feels that anything within this manual will be of value, this will be available to you either online or in hard copy. Just reach out and we can get them in your hands at any point in time. So with that, I will just kind of close this up with, does anybody have any questions for John while we have him here? And that is, I will take a little bit of a personal time here. This will be John's last time with us after over 30 years with the IODOT and over 10 years at Concrete Pavement Technology Center. John has indicated to me last night that he is retiring in July after over 40 years. So let's just give John a big round of applause. Big thank you. He's been a big staple in this conference here for a number of years.